This is the I Am a Mainframer podcast, brought to you by the Linux Foundation's Open Mainframe project. Episodes explore the careers of mainframe professionals and offer insights into the industry and technology. Now, your host, Senior Analyst and Vice President of Sales and Business Development at Futurum Research, Steven Dickens.
Hello and welcome to the I'm a Mainframer podcast. I'm your host, Steven Dickens, and I'm joined here today by Shuang Chen from the Weather Corporation. Hey, Sean, welcome to the show.
Thank you, Steven. Happy to be here.
So let's dive straight in. Tell the listeners and viewers here a little bit about your current role and what you do.
Weather Corporation is a new venture and just a little bit over 1 year old, but this is would be the third large project for me using the Mainframe, the latest computing platform. Weather Corporation is working on a very exciting project. We will roll out a sustainable local climate adjustment solution to anywhere in the world, powered by the most powerful computers and the AI platform.
Fantastic. So let's maybe start here and get a picture of you. The show is called I'm a Mainframer. Really want to understand a little bit about your journey. So maybe take us back, Sean. You're finishing college, you're starting to enter the workplace. What does that first role look like? And where do you start your journey in IT?
I started journey IT a long time ago. And when I finished college, I went to graduate school. So I was in the AI area, so-called today's AI. There was like 40 years ago, AI was very theoretical parts. So the mostly is the pattern recognition, image recognition, voice recognition, machine vision, called machine intelligence. And that's where I started my first master degree. I have more than one. So first master degree is on the a breakthrough speaker independent speech recognition, that's the first time I got into the AI and no neural network. That's very simple ones. And because the computing capability at that time was very limited, but that was first I get started.
Okay, so maybe what was that first career move? Where did you go first, Sean? Where was the first company you worked?
For the first company, that was after when I first got into industry research, that's during my later stage of my PhD. I did some intern work in Bell Labs in New Jersey. That was on the computer vision, and which is also my PhD thesis. That's first. Then right after that, after my PhD, the first real full-time work, it's in Silicon Valley. So I worked there for 5 years. Also work on the first generation of the handwriting recognition for the mobile device. If you remember, that was Apple has a so-called Newton, and Microsoft have the so-called the pen window. And the startup I'm working with in Silicon Valley becomes a third competitive provider along with IBM. IBM has its own, then this company provides its own handwriting software, and eventually licensed by all the large PC manufacturers, including IBM. I was leading that efforts, and eventually the company went to NASDAQ and etc. Yeah.
Fantastic. So when did you first start working with the mainframe? When did you first get onto the platform?
Yeah, in the past 20 years, now it's 2023, I've worked through several mainframe large systems, some largest systems in the world. So my first large project was mainframe is starting from 2003 until 2011 or 12, and I was the chief engineer of the one of the largest ticketing systems in the world.
Okay.
Yeah, we used the mainframe. I think at that time the Z10 and the TPF. So I worked very extensively with just about all the largest ticketing system in the world, from airlines, United, American, Delta, to the GDSs, Travelport, Sabre, and also was the I said some largest ticketing system or transaction system in the world, including Marriott and Trenitalia, SNCF, and even Visa. So
So we don't get many people on the show who've got a TPF background.
yeah, that was the first one. Yeah, the second
so
one.
maybe tell us a little bit about your time working with TPF. It's some of the biggest mainframe deployments in the world, but not many customers in that space, and pretty. As I say, we don't get many people on the show who've worked in the TPF space.
Okay, TPF I think stands for, if I'm wrong, correct me. I think it stands for transaction processing facility. It's a very traditional acronym. However, as we know, the mainframe was built in the 60s, late 60s, last century. Actually, mainframe was not built as a theoretical computer. It's built as some foundational economy needed a computing platform. So the mainframe design from beginning is to one of the enable airline reservation system, and which is ticketing system, real time, and retail, like one of the largest one is Sears, right? Then banking, like a CICS. So we all know KICS. So TPF is one of them, built from the right beginning. What I mean the right beginning is that at that time the mainframe was not like today. So you got a operating system, then you got a middleware, then you got a application, you got a front end. No, the mainframe was a one computer, monster computer with all the blue screen terminals, right? Or green screen terminals. So all the transaction, doesn't matter anywhere in the world, or all the travel agencies and whoever, or all the airline counters and backend connect to the mainframe. So the mainframe designed from bottom up, from every bits and the bytes, bottom up for that purposes. So they have the most criteria for the real-time ticketing system is that you have to handle very large scale simultaneous transaction, and means that how many transactions per second, and very reliably, very fast, and also maintain basically, you can say 5 nines or 6 nines, whatever the availability is. So in practice, I know that some largest ticketing system, even today, they've been using TPF still in the back end, nothing to replace it, because if you replace, you're going to do the same thing, and it just with another name. So they have like for years, for many years, a zero downtime. Those are not even scheduled downtime. When you do maintenance, when you do database consultation, whatever you do, they don't need to turn down the machine or stop the application. That's what's mainframe. Then top of that is very secure. So security, reliability, and availability on top of those large amount of transactions. I can give you an example since you're asking TPF. There's you heard the word the PNR, right? And on all the airplane reservation today, you have a record number. When you make a reservation in the travel portal or Sabre or something, you got a record number, which people also call a PNR. That stands for passenger name record, PNR. So every time you got an order, you got the query, they book, they got an order. So you have a PNR. in order for mainframe to handle this in the fastest possible way, the PNR number actually is the address on the disk for that record data physically located. So you don't need another data lookup table or index database. No, you just get that data and get to the address, get to the order.
So it's a completely different, and I mean, I know this about TPF. I used to have the pleasure of sitting by one of the distinguished engineers who had a background in TPF, and he told me about, from a system design perspective, it's just completely optimized for transactional speed. It's not using any of those constructs that you would expect in sort of classical computing,
right?
Where you've got a database, you've got middleware, you've got a sort of transactional front-end layer. It's really, as you say, purely designed to drive transactional speed. So let's move forward a little bit here. So you spend some time on TPF. What's the next role that you do after that? Where does your career take you next?
Yeah, so we will just quickly wrap that one. That one's significant because we needed to build is the largest ticketing system in the world, and the people never seen that large. It's literally designed for 5 billion tickets per year. Now, each ticket is involved in many transactions. So not just one transaction. You got a query, you're going to book. A lot of people query, never book. Right? You got to book, but a lot of people book, never confirm. Right. So you have to pick the date, pick the trip, departure and arrival, and time on that, and you have to make sure the ticket's available. So when you book, you have to confirm it. So once you book, the seats is reserved for you shortly. Then you have to confirm. So there's many transactions. And 5 billion tickets, that's translated to a huge amount of transaction in terms of the current market. So basically, if you add, that time was about 500 million tickets per GDS. There's 3 large GDS, there's a number of small ones. So if you add all the 3 large GDS together and times 3, also not even 5 billion. So you can see how big the ticketing system is at. So in order to do that, the industry put the best together, including IBM TPF solution. There was a huge x86 solution, which is best the computer from HP called Superdome, and then best software from Oracle, Oracle Cluster Enterprise. Then that's another system. So basically, the 3 largest solution system you can put it together, and then we ran about a 6 months proof concept with the same data set, same criteria on the 3 different sites and different teams. They have to really run through the computational results, then eventually compete. In that sense, it's a large project. So TPF went out. That says something about this fundamental system built on the mainframe.
Mm-hmm.
So the second one was based on that later on during this 2014 to 2018, 2014, 2017. So that's the first time when Linux 1 announced. And that time we are building the largest e-ticketing cloud service for the bus industry. The previous one was for the rail, and this is for the bus industry. The bus industry is even bigger. Was a 20 billion tickets a year industry, but we're not trying to build a system for 20 billion tickets. We break out for each provincial markets, which is roughly about 1 billion tickets a year. Still quite large. But mostly is that you're going to have, instead of one customer, you have many customers, hundreds of operators. So we provide a cloud service. They don't have to do anything. They just open the interface for their ticket inventory every day, because they change all the time. And we running in their brand about all the transaction and the sales channels and the back end transactions, because you have to maintain the high integrity of this ticketing inventory, because you cannot sell one season twice or more than once, right? So we run websites, mobile apps like iPhone and Android, and the ticketing machines like kiosks, and even we run this boarding machines which you need to check the tickets. So once ticket is boarded, you cannot board again. So this is among all the stations. So we have a one system running for all of our customers. So we started with one customer, then later on becomes a pretty routine process. Whenever we sign, the sales team signed an enterprise, it's all enterprise customer. When we sign the transportation group, then we have a routine. Basically, in 2 weeks, we'll bring all of the stuff online. And before, they have all kind of a problem, and they're totally new to e-ticketing. They have no IT team do that, and have some of the customer put on their websites, and they get hacked all the time. And so when we do that takeover using a mainframe support, that was a Z12 on the Linux one, and we get rid of all those headaches. It's safe, reliable, and we only have one system to support. We have a very small IT team, but it also runs very, very smooth, very well.
Okay, so you moved from the online sort of travel world into a ticketing space for buses. Tell me about what you're doing at the Weather Corporation, if you can maybe spend a little bit of time, understand that's maybe pre-launch. So share what you can with the listeners here, but really interested to know what you guys are doing.
Yeah, at this time will share you with a high level. And basically is that we use the historical weather data on the real-time sense data, large amount of thousands of sets, and the train using deep learning train and neural network models, which can basically after trained, that becomes you can imagine it becomes a smart meteorologist, right? And they can predict constantly based on the weather change. They can predict that a specific airspace, specific weather parameters, and 10 to 15 days ahead, just like weather forecasting. By doing this, we can accurately model model the entire airspace for the weather point of view, entire model that for any given region. So combined with another technology, and the founder of this company has been working on for the past 15 to 18 years. It's proven in the markets. And that technology basically using a charged particle way, or called ionization way, to convert the moisture concentration into water, fresh water. So when the Mother Nature is not ready to rain, actually Mother Nature, as we observed every day, 90% of chance when you have a moisture concentration, you don't rain. And it's only less than 10% chance when the Mother Nature lined up things together, temperature, pressure, wind, and they're going to drop rain or snow. So Weather Corporation's new solution is using this, fully leverages AI, and we established the detailed weather model, so that we can combine it with the rain-making technology, so we can intelligently leverage whatever the moisture concentration blowed over your space, and we can have a strategy to make it rains, make it fresh water. Remember, the fresh water is something you cannot dig from ground, and you cannot make in a factory. It's nature. So the fresh water we got today from the rain, it's the same water, from the last ice age, right? The last dinosaur was about 120,000 years ago. That's what the same water. You don't get more, you don't get less. Yeah.
Fantastic. Sounds fascinating. So Sean, I always ask a couple of questions on the show, and I'm super fascinated to get your answers. You sound like you've had a really eclectic and sort of interesting career over the mainframe. So maybe let's start to look ahead. You've got a crystal ball. You can start to look maybe 3 to 5 years out. Where do you see the mainframe in that time horizon? Where do you see things going?
Yeah, I'll just give a perspective from my own point of view. I could be wrong, but with my past 20 years on the different mainframe, we do have a good sense of the past and the corporate priority and strategy of IBM. So what I see is that mainframe, probably as the only left mainframe computing system, it's as a very solid, high integrity computing system. It will continue to play the backbone of many of aspects of the economy. Just consumer don't see it. Ordinary people, you don't see it. And you call 911 and you got a response. A lot of people don't know even 911 was like in Los Angeles or New York. The 911 is running on TPF, and for many years. And there's many examples on that. So what I see is that mainframe in a few years from now will be integral parts of this IBM push, the so-called hybrid cloud. So you have quantum computing. By the way, IBM is the first commercial quantum computers is in the field now, right? It's installed and running. And this year we'll take a second generation with more than 1,000 qubit. And the first one is about 432 qubit as Osprey. So it's already in the customer sites. I know there's a pipeline there, and there will be more than, of course, will be more than one customer site. So with this hybrid cloud platform and a framework, then you have anywhere from a quantum computing to the mainframe and to the edge computing, and from private to public cloud. So I think those will continuing playing a critical role. Other system is very hard to replace.
Yeah, I would agree. The other question I ask of all the guests, and I'm particularly interested in your answer to this, what advice would you give to the younger Sean as you were coming out of college? So you have the opportunity to go back, speak to yourself kind of age 21, 22, with the experience of hindsight. What would you be saying? What would be your advice be?
There'll be everybody has their own life paths, and there's so many exciting things to do right in your lifetime in the world. And you ask me, that will be a very biased from my view and my past. AI. If you have any interest in that, get on the AI.
I think that's very good advice for the time.
Yeah, it's not just because of buzzword. And I told you my first master's was on AI 40 years ago. So you can say I'm biased, but if you see from the 80s to now, and you were
just a trendsetter, Sean. That's all it was. You were a trendsetter early in your career.
Yeah, you don't have to see very far, because right now the CPU and the computing infrastructure has been reached a critical point that that a software can run fast enough. Now you have a better algorithm called the modeling, right? The deep learning, and so that's what AI based on mostly. Now you can handle a huge amount of data, ocean amount of data in a fast speed. You can have so many ways you can change your life. We're working on the weather. Climate was definitely one aspect, but there are so many ways. And if they just get off college and they can catch up quickly within a few years, there will be you take the ride of this wave, you will do something very, very exciting.
Yeah, I'd agree. I think that's a great way to wrap here, Sean. I really enjoyed the conversation. Everybody, you've been listening to the I'm a Mainframer podcast. I'm Steven Dickens. Please click and subscribe. We'd love to have you connected to our community here, and we'll see you next time. Thank you very much for listening.
Thank you for tuning in to I Am a Mainframer. Liked what you heard? Subscribe to get every episode, or watch us online at openmainframeproject.org. Until next time, this is the I Am a Mainframer podcast. Insights for today's mainframe professionals.